Flip note 37, finding particular solutions. Find the particular solution of y if the derivative is 3x squared minus 1 and passes through to 4. So this is a point on the original graph y, so it's going to help us find c. Okay, so what I'm going to do is I'm going to separate the variables. It's really not necessary since you don't have any y's over here, but I'm going to go ahead and pull dx to the other side. Multiply both sides by dx. Bring in your integral symbol. Integrates back to y. X cubed minus x plus c. To finish finding the particular solution, because right now we have the general solution, you're going to plug in 2 for x and 4 for y. Subtract a 6 on both sides. It looks like I'm going to get negative 2. I'm just going to come up here. So the solution to this differential equation is this cubic. That's a solution. A solution just means the original graph given the y prime. Okay, so another problem here. Find the particular solution. All right, it's not written in the dy over dx form, so I'm just going to go with it the way it is. Getting this side, getting it ready for integration, I'm just going to pull that x to the fourth out of the denominator. Just wanting to pay attention to my answers, my solutions should be greater than 0. So it's just kind of there. It's not really going to come into play for what we need to do. I'm going to bring in the integral symbol. And if I do so, I need to bring in the dx. So this is going to go back to f of x. Increase the exponent by 1 to negative 3, divide by negative 3, plus c. All right, so this is actually your x and y, or if you want to call it x and f of x. All right, so I'm going to do a little cleanup at the same time I'm trying to plug things in here. So 2 equals, that'll cancel. Then I'm going to have, maybe this wasn't a good idea. Then I'm going to have negative 1 over x cubed, and x is 1, so that's just 1 cubed, plus c. So 2 equals negative 1 plus c, c equals 3. All right, so just coming back up here. All right, so the particular solution is going to be negative 1 over x cubed plus 3. Well, let's take a look at another one. All right, this one's a little more involved. They give us an acceleration equation, and then it gives us some information about the velocity and the position. So let me see if I can kind of put this all together. All right, that's given. Velocity is 25 at time equals 3. That would look like this. This is a point on the velocity graph. Satisfies the velocity equation. And then the position is 10 when time is 1. So I'll just use x, since this little guy's moving back and forth, left and right along the x-axis. All right, what's the equation for the position function? I have to integrate twice using each of these initial conditions. So bring in the integral symbol and the dt. All right, I'm just going to go back to v of t for the antiderivative. Here, this integrates back to 3t squared minus 2t. Don't forget the plus c, because this is where you're going to want to plug in these values. So when time is 3, v of t is 25. So plug 25 in here and 3 in here. So 3 times 3 squared minus 2 times 3 plus c. So 27 minus 6 plus c. Ugh. That's 21 plus c. Subtract 21, so c is 4. I have to find c before I can integrate to get back to the position equation. All right, so let me rewrite that. Okay. All right, now I'm going to integrate again, and I'm going to bring in the dt. Velocity integrates back to x of t. T cubed minus t squared plus 4t plus c. All right, using our initial condition. So time and position. 10 equals, and we're going to have 1 minus 4 plus c. So those will go away. I'm going to add a 4 to the other side, so it looks like c is 14. All right, and let's just go ahead and replace that value in for c. Okay. All right, so we've finished note card number 37. Now it's time to look at note card 41, which is an extension of this. So I'll join you there here in just a second. All right, so these are going to be a little more complicated. All right, find a solution, and they're calling it y equals f of x to this differential equation. That's just a derivative. A lot of times students go, what are they asking me to do? Well, to find a solution, if they give you a derivative, means find the original equation. And this is to help us find c. All right, we're going to separate the variables. So I'm going to multiply both sides by dx. So I'm going to put the dx up top here. And then I'm going to multiply both sides by e to the 2y. So that's going to pull it out of the denominator, and I'm going to end up with e to the 2y dy equals 3x squared dx. Okay, so I have y's on the left, x's on the right. Time to bring in the integral symbol. All right, I'm going to use u substitution here. If u is 2y, then du is 2 dy, which means I need to bring in a 2 and pull out a half. Okay, so if we can kind of do this mentally here, we can see that this is going to be a half e to the u du. Well, that's going to integrate back to e to the u. So I'm going to have 1/2 e to the u, or 2y, x cubed plus c on this side. Plug in 0 and a half for y. So 1/2 e twice a half, x is 0. This looks like it's going to go to just e. So a half e over 2 equals c. All right, so let's see if I can go back and find out where I was. I'm going to pull this back up here. So the equation was 1/2 e to the 2y equals x cubed plus e over 2. All right, notice the directions say for us to find a solution that is solved for y. If it had just said find a solution, I'd be done. But it wants it in the y equals format. So let's multiply both sides by 2, which clears that fraction. That's nice. Let's get y out of the exponent position, so let's bring in a natural log on both sides of the equation. That all wraps up like that. Those cancel. This now becomes this expression on the right-hand side of the equation. Divide both sides by 2, and you're done. I've satisfied the requirement of putting the solution in the y equals format. All right, taking a look at this one right here. If the derivative equals 2y squared and they're giving you some points here, or at least 1 point. If y is -1 when x is 1, then when x is 2, what's y? Well, I think without saying it, I'm going to have to go back and find y. So I'm going to separate the variables. I'm actually going to only divide out the y squared and leave the 2 with the dx. Okay, I see this as pulling this out of the denominator, y to the -2 dy, and doing a reverse power rule. So increase to -1, divide by -1, which is just negative y. And this goes back to 2x plus c. -1 over y equals 2x plus c. Okay, I'm going to plug in these values here. -1 over -1 and twice 1 plus c. So subtract the 2. It looks like c is -1. I'll come back up here. Looking at this equation right here, I think it was -1. And I'm not finding y. I just need to find, well, I'm not finding the equation. Okay, y equals, I'm finding a value for y when x is 2. So I'm just going to plug in 2 right now and figure out what y is. So 2 times 2 is 4. 4 minus 1, 3. Take the opposite of both sides. And I'm actually just going to reciprocate. I'm going to flip here and flip this one right here. So I'm going to get y equals -1/3. You can just simply reciprocate both sides. Let's separate the variables. Divide both sides by y squared. So actually, it looks like that last problem that we just did. Let's go ahead and pull up the y squared. Bring in the integral symbol. Ooh, that should have been a negative. I don't know if it just disappeared or I left it off. That's a -2. Looks like it just disappeared. All right, reverse power rule. This is going to be -y to the -1. 6x minus x squared plus c. Oh, great. We have to find the value. This is x, this is y. All right, I'm going to clean this up a little bit. This is -1 over y. And then I'm going to plug the values in. So y is 1/4. So -1 over 1/4. Well, yeah, I'm going to make that -4 in my next step. 6 times 3 minus 3 squared plus c. Okay, this appears to be -4 equals 18 minus 9. This is 9 plus c. C equals -13. Maybe about right here. -1 over y equals 6x minus x squared minus 13. Okay, I know it's a little uncomfortable, but like on the last problem, let's go ahead and find the opposite of everything and then reciprocate. So +1 over y is equal to the opposite of all the terms over here. Yeah, everything looks good. And then I'm just going to flip. Okay, I'm going to put this all over 1. So y equals 1 over this expression. Kind of strange. But easy enough, not too bad actually. Okay, so that's finding particular solutions.